Okay, for people who are joining this live stream, this is one of an infinite series of meetings about language completeness and consistency. We have a variety of topics. First topic, overwrite target default for copy file.
Yeah, and it's somewhat misnamed because the conversation evolved from when this agenda item first came into existence. But so export in 12 added a new value to create overwrite target and create archive and extract archive are apparently adding more values. And then there's some question of, exactly how are these implemented? Do we want to move them to other functions, etc.?
Well, I mean, what's the complete inventory of file writing functions? It's pretty big. We certainly know what it is from sandbox stuff and so on, right?
Well, the sandbox doesn't operate at the function level. It operates at the file system level, so it is completely agnostic to those things. But we do have an inventory of functions that Devin, right? We came up with an inventory of things that take
file convert obviously is one.
Yeah, we have an inventory of functions that create intermediate directories and overwrite target.
Whatever that background noise, it'd be good to get rid of it. What is that?
Sorry, I was just getting housekeeping out of the hotel room when you joined the meeting, so it should be quiet now.
I'm not even going to ask what even continent you're on, but okay. Let's see. So where is that list?
Devin, can you send that?
Yeah, sure. It's in a Jira ticket. I'll try to retrieve it. Oh, wait. Yeah, 1 second. Sorry.
Right. So then there was so this whole conversation started from.
I mean, there's all kinds of stuff here. I mean, there's encrypt file, decrypt file. There's all kinds of things.
Right.
I have no idea whether this has been consistently done.
Right. Well, the question isn't what has it been done for, because that's a slightly orthogonal question. Well, I guess there's a question of, and this was a question raised by Jan, I guess, was suggesting that Cloud Deploy, Cloud Publish, and Cloud Put should probably.
Yeah, absolutely. That's a great idea.
And then the question
that would be a good way to parameterize what that behavior.
Right, and so for
because right now, okay, what am I looking at here? Am I looking at this whole thing? Okay.
Right.
Yeah. Okay.
Right. So that's the list of things that currently take overwrite target, and for example,
no,
right.
This one both options. Okay.
Yeah.
Okay, well, that seems to me to be a very inadequately short list.
Well, I mean, there's a question of, well, I mean, I'm not convinced that every single, obviously, open read, I don't think open write should take an overwrite target. I mean, that's a low-level function.
Yeah, I kind of agree.
Right. So, I think basically.
All right. So listen, overwrite target for Cloud Publish. Is anybody from the Cloud team here? I mean, Cloud Deploy, Cloud Publish, Cloud Export.
Yeah, Jan's
that
here.
Sounds like a good thing to have.
Yeah, for sure. And specifically, I mean, these functions, they already override targets by default now, and I think that should stay that way. But it would be good to have that option just to make that clear.
So right, and so then now is that
so with false it will fail with a message, right?
Yep. And what we're thinking to change actually in the cloud is copy file. So right now, if you copy file to a cloud object, it also overrides by default. But I think we all concluded that that's wrong. And it even
God, how much code would that break to change that? What does copy file do in the desktop? Does it warn?
It fails with a message. The default on the desktop is false.
Okay.
So
well, the cloud should be the same. What should keep both do?
Well, I mean, so first of all, keep both isn't supported everywhere, and I'm not completely convinced that it
What
makes
does it do?
sense.
I have to rename one of them.
Right. So what it does in export on the desktop is it keeps the name, and so the old one is not modified, and the new guy gets a space 2 added to it, which I'm not sure why it's a space 2 and not _2 or something more friendly like that.
I think it should be a --2.
You know, and I presume if there's so if Sean or somebody from import export is here, which yes, Sean is here. Yep. Maybe he can speak to
-- copy. I don't know. If there's only one of it, there should be a -- copy or something. I mean, if you copy the copy, it's -- copy -- copy.
Sure. Okay. Everything that implements it uses one common utility function, so I can change it in one place.
Right, but it only ever makes one of it, right? If you want to do this again and it was going to overwrite that again, does it do --3, noting that there's a --2, or does it do --2 --2?
Yes, it changes it to a 3.
Okay.
Right, and so you're repeatedly giving it the same original name. So I think that probably a numeric. I mean, maybe maybe we for the first one we just do -- copy, but if that's
no, it's wrong. It's wrong. A --2 is fine.
Okay.
Okay. Extract archive. Append. What the heck is that meaning? Overwrite target arrow append?
So for extract archive, that means if some of the files exist, but others don't, then it just extracts the new ones.
I don't think the word append is very good for that.
Yeah, it doesn't.
We chose append because we kind of use it in other places too. So like some formats already use append for overwrite target, like HDF5. You can append to a file.
But this is appending to the file system.
Right.
Yeah.
I mean, to me, that's a much more an automatic setting for overwrite target, that behavior.
Wouldn't that be better, something like only new for extract archive?
Yeah, by the way, you sound like you're in a cave.
So the current behavior of extract archive, or, well, I guess I don't know what its default, but I suppose if you did overwrite target goes to false, then it will fail if any file in the archive already exists?
Correct, and that's the default.
Okay. Right, so it could be new only. I would be okay with that as automatic. I mean, we haven't defined what automatic means for any of these functions. So
I think that makes sense.
It seems like a very niche thing, and I almost thought that automatic would have been the right thing for keep both.
I don't think so, actually. I don't think so, because it's... I don't think so. I think that's a very weird behavior that I think can have its own name. Automatic is sort of between true and false. I think it makes sense for this. And I think there may be other places where that's... override target.
But then automatic is going to mean different things in different contexts.
Well, automatic doesn't really, well, I guess automatic to the extent that it's supported is either true or false, depending on the implementation.
Well, isn't it the case that overwrite target to true and extract archive will rewrite every file? Is that correct? So I have to say, I think automatic is the intermediate case between true and false. And I think that's relevant for directories. It'll be something that will happen regularly for copying. Like if you copy a file into a directory, automatic should mean put in the new files but leave the other ones unchanged. See what I'm saying? Does that make sense?
I mean, I don't think we currently support sort of a copy file or copy directory like that, but if we did, then...
Well, we should. I mean, and something we need to do in the cloud sync stuff, we need that. I think this is what we should do. Override target to automatic means if it's a directory worth of stuff, you're only putting in the files that didn't already exist. Let's move on. I think we've got a solution here.
Okay.
Anything else to ask about this?
I wanted to discuss for the cloud thing, two things about the cloud things. One is, so would these only be true false, or would these also have keep both? And then what would the behavior be in keep both? Because I don't think you can in general just add a --2.
Why? Why can't it just add --2? Seems reasonable to me.
But a lot of cloud thingies are UUIDs, and then it's no longer a UUID.
Okay, hold on. The case where you're saying cloud publish, if you say cloud publish without a second argument, right, and it generates a UUID, obviously it's going to generate a new UUID.
Yep.
If you have a second argument, it's because you specified something to be the second argument. If you publish, I don't think we even let you publish onto a UUID. Do we?
You could construct it yourself, and you could choose one that already exists, but I don't think we should.
Well, I think with the new directory structure, I think we'll know if it's a UUID, won't we?
Right, but
no, wait a second, stop. Jan, can you answer that question? Isn't it the case that we're putting the UUIDs in a different base than we're putting things which are in the home directory and so on? Correct?
Yes, but that's already the case. I mean, that they don't.
Okay, well, fine. In that case, we could have different behavior if you try to. I mean, I don't even know. I don't know if you can construct. So what you're saying is, if I say cloud publish and then I give a cloud object as the second argument, right? And that cloud object is a UUID cloud object, and I say overwrite whatever target arrow keep both, right? Then I think it should know that it's a UUID and generate another UUID. Adding a --2 to the UUID is just nuts.
No, that would be completely silly. But even generating a new UUID, I'm not totally convinced.
Why not? If it's a keep both situation, I think you want to generate a new UUID because these functions return the place they put things. So it's not like you lost the UUID. Do you see what I'm saying? I think that will work fine. I mean, cloud deploy on top of that UUID with overwrite target to keep both, and it generates a new UUID. Seems reasonable to me.
Okay, yep. Why not?
There. And returns it to you.
Right.
I also wonder about the other direction, and it's sort of a general problem because we support copy file from the cloud to the local file system and the other way around and so on. And there's probably other things like local objects and so on. So I wonder how can we avoid that we have some exponential explosion of implementations of keep both, for instance.
Well, it's an implementation question. I don't know the answer to that. But I mean, in other words, if you're doing a copy file onto a local object, I think it should be the same deal. I don't know how to recognize a UUID local object, but I think there is a way.
Right, and my other my other question that we didn't get to is so if we do cloud put, then what about put? And if we do put, then what about save and dump save and probably other things I haven't thought of right now?
I think one issue with put is a syntactic issue about its argument structure, if I remember correctly.
Yeah, it's not, it's var arg, and right, the thing to write is the last.
Yeah.
Oh, it does take options. Okay, so I guess if the last things are rules, then it lops them off.
Fine. Okay. I do believe it will be a useful option for all of these. Put, save, dump, save, all of those. I think it would be a useful option.
Okay.
I mean, basically, it's a right now, it's very kind of, I don't know, old-fashioned Unix shell-like. It's just boom, you put the file there, no warning, no anything. And I think it would be good to have something that has some protection.
And create intermediate directories.
Yes, I think so too. I mean, I assume it does that by default right now, but I think that should be parameterized. Don't see why it shouldn't be.
I don't think it does. I think it'll just fail.
Well, I think it'd be very, very useful if it. Yeah, actually, you know what? I think I noticed that even like yesterday. I was using, what was I using? I was using export, which doesn't have this either. I mean, create intermediate directory would be very useful in export.
Mm-hmm.
I'll add it.
There's some missing function that I noticed. Yeah, here's a bizarre missing function. Okay, now maybe I'm just being silly, but if you do I've got, actually, maybe this is just silly. Maybe I have to use file name join, and then I say directory, and then I say foo or something. Does that just do the right thing? Yes, it does.
Right, and you can also do a file name expand of foo is the function I believe you're looking for.
What does that mean? File name expand, what?
Or is it, maybe it's expand file name rather than. Right, it takes a file name and turns it into its absolute file name based on.
That wasn't actually what I was looking for, but actually maybe file name join is enough. I'm just. Oh, I see what you're saying. I see what you're saying. No, that is what I was looking for, because that is get me the name of a file in my current directory.
Mm-hmm. Yeah, so if you give it a name with no file name component, it'll give you the name. And if you want to verify that there's also absolute file name, which will also check that whether or not that file exists.
Fair enough. Okay. I wonder how well documented all of that is.
I think it's reasonably well. I mean, those two functions have reasonable ref pages, whether.
Fair enough.
So.
All right, onward.
Right, so, right, this was spun off from the de-experimentalization meeting of base encode and base decode, and I hope that Dorian is here because he's.
I'm here. Yeah. Oh, sorry, I'm here.
Right, and so there was a question of
all of the various zoos of encodings. I mean, we should have as many animals from that zoo as we can easily capture. We should get.
Right now, so one question is, what can we get from WXF? And so, Dorian, do you know the answer to that question?
Yes. So there are base 16, base 85 for sure, base 64, 5. There are at least those 3. Maybe there is one like 35, something like this. So the code is there. I'm not sure if it's really hooked to something like a Wolfram language function.
For example, here we've got a few mentioned here: base 32, base 36, base 58. And I think there's a table somewhere of lots of these. right?
Right, and then we have, variants of these, right? With padding, without padding. Sometimes there are minor alphabet differences between different implementations.
I strongly think, just like export formats, that just doing one systematic job of curating these things and putting them all in is super useful for the day that you need, base 58 with such and such a kind of, padding. It's just, it's just there. I mean, it's just like, it really makes things easier. And it cannot be that difficult to parameterize these and just put a bunch in. I don't think it's our highest priority, but it seems like a good, I mean, at the very least, this is kind of a student internee type project to go inventory these things, curate them, and so on.
Well, maybe curate them. I'm not, well, I guess the question is how hard, if we can.
They may just be parameters. They may all just have parameters. I don't know. It may just be, here's the alphabet, here's the mapping, boom.
So currently that's not how it is implemented. Doesn't mean that with some changes it could be. Also, currently it lives in a separate library, like the one that we use for WXF.
Okay.
And compress.
Right. Now, so there was one question of, could you in say an afternoon hook up, base 85 and base 16 from the WXF library into base encode and base decode? Or do you think it's a bigger project than that?
Sorry, what was the question exactly?
The question is, can you take that code and hook it into base encode quickly?
But yeah, I think that's that's not hard to hook it, and then we may realize that there are some bugs because obviously it was not used. But providing those versions, I don't think it's, as you said, it's probably half a day of work.
Okay, well then we can at least have 16 and 85, and we can start to see.
Okay, But, any idea where I should expose them, like a developer function?
No. We're going to add them to base encode via second argument. So the current default will be, base 64 or something like that, because I think that is by far the most.
Yes, that's what the default is, right? And then the other ones I think should be quoted strings, but we should also allow the integers. Right, because there may be quoted string quotes base 36 or whatever, but also allow the integer 36 as a second argument.
I think that will be confusing with integer string 36, which is different.
Okay, integer thing 36 means base 36 in a different notion of base 36, right?
Right.
Yes. So right. So base. Right. So base 16 encoding is different from hex, right? Because in hex you turn it into an integer and then you compute its value base 16, and base 16 encoding is you split it up into bytes and
Let me ask the question: how do I get percent encoding in our world?
That's a URL encode.
Okay. Fair enough. Encode is a bit old school. Though I'm sure there are systems that still use it. What do we have these things like bin hex and so on? Are they import-export formats?
Formats, no.
Do we support these things? I mean, I'm not sure these are exactly important. I think those are things we should have done 30 years ago for bin hex, not today. All right. Well, so fine. I thought I saw a list of many more base XX formats.
I put them in the chat for Zoom.
No, wait a minute. That's a list of numeral systems. That's something completely different. That's
right. If you scroll down, if you scroll down there by type of notation.
No, that's not the same thing.
Right. This is not base encoding.
Well, actually,
I mean that's base form, but that's not base encoding.
That's something way bizarrely different. I mean, that's not.
I think they are mixing there both because they have
They're
also
totally
base.
confused. They're totally confused here. Arg! Wow.
Confusion out on the interwebs? Shocking.
No, this is very, very confused. Unless people are using something like that. I'm very confused here. Base 32. Well, that's a real one. That's a real one. Base 32 is a real one. But these other ones are just not real ones, are they? Radix 50. Base 62 encoding. What the heck? No, this is totally confused. Well, okay, that's yet a different thing. I mean, that's the use of different letters to represent the high order bits. I mean, as you say, if I say integer string.
Right, so if you do integer string of base 64, that's something completely different from base encode. Because integer string of base 64,
it's too big.
You can't do that. You have to say base 64.
Here, I can say base 64.
Yes.
What the heck is that?
Well, that means use the base 64 alphabet, which hopefully is the same base 64 alphabet as we're using in base encode, to represent the, this integer written in a base 64 number system.
I see.
And in the case of base 58, it's the same, the encoding and the integer string.
Are they?
Well, it's conceptually the same, right? So what that's doing there, it's using I believe the Bitcoin base 58 alphabet to represent, extend 30, because traditionally we were limited to 36 because that's what you get from 10 Arabic numerals and 26 English alphabet letters. And so this is doing the same thing using the alphabet defined by those encodings.
Wait. So in addition to 36, it's adding
58.
22. What the heck? It's not adding the whole alphabet? It's not adding the uppercase alphabet?
No, it's never done that. And I think that would be ambiguous, right? We couldn't take data out from the world if we treated FF.
Oh boy. Am I confused or what? Look at that. N, it's trying to avoid the L confusion.
Right. And it starts with 1, so 1 is 0.
Right, yeah. You really wanted N from 0 to 57 in base 58.
And what's that 21 doing there?
Because you're in base 58, right? You wanted 0 to 57.
So
it's omitted the lowercase l just for entertainment value.
Well, to avoid confusion and to be something you can read in an easier way.
I thought it was to avoid, back in the day, typewriters used not to have 1 keys because you used the L key instead.
But also it looks like it doesn't have zeros or O's, at least not an uppercase O because of that confusion.
Right. So that's something you can read without confusing the letters. That was the idea of base 58.
Okay, so very, very different from a base. By the way,
but in this case, Bitcoin addresses,
right? I mean, these are the digits you use to, right? This is right. This is base in the math sense, in your fourth grade new math sense, right? It's just instead of going from 0.
Yeah, I understand. It's got some weird set of digits.
Right, and the same thing would be for base 64, right?
Right.
They're using the same, right, the same value that they have in the base 64 encoding.
By the way, we should give this can somebody add this to the page on integer string?
It is on the page.
What's that?
It is on the page.
This example?
It should be, or some variant thereof under properties and relations properly. Might be under scope.
Doesn't
right. So yeah. So that last one with base 64. I guess it's not literally that, but it's.
No, that's not.
But I think it does. It's conceptually the same thing.
Okay. Could we actually put these in, because this would be very useful to people to just see.
Okay.
Okay. Fine. I understand what these are now. Okay. So, by the way, I would make the argument that we should extend this 36 to 36 plus 26 and use the uppercase letters, just because it is sometimes convenient to have that. Making sense? Yes. You understand?
I'm not.
Look, it's a corner case, but I've certainly needed it.
And would it be better to have an option to actually set the alphabet you want?
If you do that, you might as well do the mapping yourself. It's not exactly the world's most difficult thing to say integer digits and then map everything. I mean, unless there's some obvious choices of alphabet, but I think we should extend this, because just as a default thing, it is useful to have more, to have the ability to have more, higher bases. In particular, do we get to, this is pathetic arithmetic failure, but we don't get to base 64 this way.
Yeah.
Anyway, I think we should extend that. I think it's a minor thing, but I think we should extend it. I don't see any reason not to extend it. It may be convenient for some purpose. Okay, is there any more to discuss with this, other than the desire to add these other standard bases to base encode? Yes? No? Can we go on, please? Okay. If we had a gavel, we would be using it. Let's go on.
Okay, so this is function that apparently, so I did a sort of an analysis of this generalized MapThread function that Sander wrote, which I think, I think it has some, some obvious ideas and some problematic ideas. And then in the other section, I have, a couple of other points of things we should do with MapThread.
Okay. Okay.
Right, so that's a ragged, right? It's an obvious generalization. It's the same list structure in both slots.
That should just work, I think.
Right. Yeah, I mean, it doesn't just work, but, well, I mean, there is a little bit of an idea, right? I mean...
Right now, does it require... It doesn't require rectangularity, or does it require rectangularity?
It does require rectangularity.
That seems unfortunate. I mean, just conforming seems adequate.
I agree.
Okay, now this case is much trickier. This next case. Really?
So that, I think, should be an error.
Well, maybe a warning, but it goes ahead and does it. I don't know.
I don't see what the rationale is for treating all except the longest list as atoms. That just seems...
No, that seems crazy. Okay, I admit that I think that's crazy. That's not what thread or anything. Thread just gives an error in this case.
Pretty sure.
What does thread do in this case?
No, thread duplicates.
Threads only supports one level.
Isn't there a multi-level thread thing?
I don't think so.
No. So it never has this issue of non-conforming pieces.
Exactly.
If thread is given something like it errors out.
Yeah, but if you replace that second 1,2 with just a 1, then it will become 1, 1, 2, 1. Yep.
Yeah, then it duplicates. I agree that with a conforming case, it should just do it. The non-conforming case, I guess I think it should just generate an error.
Mm-hmm.
And I don't think it's the right thing to have this shorter, longer thing going on. Now, this one here, what about that case there? It's very unstable to have one of these work.
Right. I'm suggesting that that maybe wants to work with an up to spec.
Where does the up to go?
In the level. So wait, this case is slightly different, isn't it? Yeah.
I was so pleased today to find out the graphics know that Partition works with up to. I mean, of all the confusing things in Partition, honestly, there is an argument that we should put the up to case right in here. That we should put it right there to help people who otherwise are going to be lost dealing with knob values and things in Partition. Any comments from people?
I'm in favor.
I don't think that adding a 9th, or is it a 10th template?
No, but I'm suggesting that we put it as a second element here because these two cases are very common, right? And the case of up to here, partition of list up to n, is super common. By the time you're down in this noise here, you know, those are much less common.
I was going to say some of those later ones could even be removed and handled via table later in the notes.
Yeah, I don't like that very much. But I know this is look, ultimately this function should get options, like padding options. I don't know whether, are there padding options that could be reused from image processing and so on that we could give as an alternative to this argument structure?
I don't think there are enough.
Well, but they may not be enough for everything, but they're just being able to say padding arrow whatever and cyclic arrow whatever. I mean, the full specification here is useful. It's not like anything here is absolutely useless. It's just hard to understand.
Mm-hmm.
And if you need it, you need it. But, you know, the up to case, the partition with an up to, just seems super commonly useful. And I would favor putting it right in here. Anyway, separate discussion. Maybe somebody could look into that and see whether it makes sense. At the very least, we could have it in one of the first examples here.
Yeah, I'm a bit surprised it's not in one.
Why don't we put it as a fourth basic example?
Yeah, I totally support putting it in it possibly even as a second basic example.
The offset is really useful.
Okay, but. Yeah, I mean,
and also the offset is it confuses you because the up to isn't relevant when there's an offset there of 1.
Right.
I put it down here, and
Okay.
The only other case that I might put in here, the only other thing that is important is the cyclic case. But the cyclic case is already very complicated because you have to say where in the cycle you start and so on.
Right.
I assume, by the way, that the cycles construct that we introduced for permutations can't be reused in any way here. Is it something completely different?
That's something completely different. I think.
Yeah, I think so. Because the cycles in partition is the padding, while here it's more like the position they would be.
No, but it isn't. It's the position here as well. Because what you're doing is you're saying, does it start with ABC or does it start with BC? You know, you're taking this necklace, basically, that is your original list, and you're somehow, I'm not sure.
Well, it would be a generalization of what partition does, because partition currently, it's creating a grid, a virtual grid of these cyclic things, and then it's placing the results.
Yeah, right.
We could rotate that grid with cycles, with permutations.
That's pretty obscure.
Yes. Yeah.
All right. Okay. Okay. But anyway, we agreed at least we're going to put up an example down here. Can somebody do that?
Yeah, I can do that.
Okay.
Devin, just create a ticket so I don't forget.
Devin.
Oh yes, yeah, I'll make a ticket.
Okay, back to this. All right. So what's the question here? The question is an up to here.
Right. So this is what happens if you have conforming but sort of not equally deep things, right? So this is sort of like the first example, only there isn't an inner list.
But wait a minute, this says at level n. It's not down to level n, it's at level n. Oh, I see what you're saying. You're saying go down to a level of at most 2, right, but it could be higher than 2.
Right. So if you look at the example, right, there isn't a level 2 sort of in the second spot, but there is, right? Because
sorry, which example? This example here?
No, the example below.
This example.
Yes. Right. I'm missing a list in the second, in each of the C3 and the C don't have a list around them. So literally I can't go down to 2. Right. And you'll notice that generalized map thread added an extra list around the result of f of 3c, which I think is wrong.
That's odd. Yeah, it's odd.
Right. So this, I think, might, maybe this should be an error, but if you say up to of 2, then, well, if you don't have 2 levels, you do it at whatever is the deepest level you have.
Right. So they're taking things as atoms, basically, that would otherwise be burrowed into.
Yeah.
Sounds sensible to me.
Mm-hmm.
Okay, what are these other things here?
All right.
Oh gosh, association.
Right. So well, I mean, right. So there's the one thing which is sort of a more specialized thing that, for Jose is super useful. We may or may not want to put it in our map thread, which is counting levels from the inside. And then
why is that useful for Jose specifically?
I use it. It's a key idea inside quantity array. It's the idea that allows us to avoid repeating the units of internal blocks lots of times, because it's threading to the internal structure of the arrays.
I see.
Right. So rather than following the repetition at the top level, it's following the repetition at the inner level.
I think I understand. I mean, but for quantity array, you won't know all those things are numbers, right?
It doesn't matter, really. I mean, we could have a quantity array in which all the magnitudes are scale symbols.
Yeah. Okay.
But it doesn't appear frequently. It's just that in quantity array, this is an important idea. So I suggested it to it.
Right. Then the other one is the bigger issue. So right now we have and this is probably a history, a historical accident of implementation, but we have the following sort of crazy behavior. In the second argument, level 0 must be a list, or it can be a sparse array, not a other kind of array, but it can be a sparse array. level 1 must be a list or a sparse array or an association, and then level 2 and deeper can be arbitrary. So we might want to have an allowed heads, or we might want to just sort of, you know.
Well, I mean, this is very entertaining, but it's completely insane. This inconsistency between these things.
What do you mean consistency between?
Inconsistency.
Oh, yes. Right, and so the thing with the background color is sort of the fundamental identity of MapThread that Jose and I came up with. So MapThread is you move, if you give it a depth n, you move the outermost level n levels in, and then you map, or sorry, you apply f at that level. So you rotate the first n dimensions and then you apply. So there's no, and association, as you know, as kind of funky as it looks, is actually following the same identity. To the extent that transpose implements allowed heads, which it currently does a pretty bad job of, which is why it's not documented. And so, right, so the question, but it certainly does seem like we should allow, maybe we at level 0, we still require a list, but it certainly makes sense that we could allow any head at level 1 and deeper.
Well, why aren't we allowing it at level, I mean, I don't understand why we're not allowing it like an association at the very highest level. Am I confused? I mean, why isn't this case here, like if you say,
well,
that? I mean, what I was thinking was something like MapThread F onto the association. A goes to list 1, 2, B goes to 3, 4. Now, why isn't that? Well, so what did that do? I'm now so confused here. MapThread would take, I see what your concern is. How do you take 1, 1, 3? The hell would you do there?
Right, so I have that basically, right, so it should be F of a couple of associations is basically, is what I say right above, right? Because when you transpose, oh, hold on, that was at level 0. So at level 1, it should be an association with key, right, so I guess we can figure out what I should say, right? You should transpose that, right, so my argument is that it should basically be the same as what you have what I have in the manipulate there. So if you did that, if you clicked on the 1 to make it at level 1, that should be the result, because.
Where's the C coming from?
Well, that's because I had I had a deeper level there. All right.
Right.
But what about the top level association here?
Yeah, so what Itai is saying is that you first transpose, so the list gets outside, the association gets inside, and then you map inside. Sorry, apply F inside, so the association disappears. The result would be then list F13, F24. Exactly what you have in the previous line.
Yeah, no, I understand.
You have to specify allowed heads to do this.
Allowed heads goes to all, I think will do what you want. And now F triple at that.
What is that doing? That's applying. So each one of those is at level 1, and it's saying take that. So the naive, that does that, but then I'm saying F apply to this. Wow.
So
Why does that make sense?
The key idea here is that MapThread contains an apply. So it's going to destroy a head at one level. And in some cases, if we have this association, it will destroy precisely the head association. So the keys disappear.
Okay, so we're thinking of an association. I have to say, I would not have immediately guessed that that would work.
Yeah, and I'm not even sure off the top of my head that that's actually documented or just an empirical observation of how apply works on associations.
I think this is correct because.
Oh no, it's documented.
Mm-hmm. Okay. The head association must disappear. So once the association head disappears, the keys cannot be there.
Yeah, no, I understand that. All right.
Yeah. Right. I don't think we really need to, well, other than knowing that order matters, but this one I'm just sort of proud of, so we should look at the fancy ones, right? So it's sort of illustrating this this principle, right? So you have the array dimensions, then as you change the level, you see how you've moved the, moved the 4 2 positions, 3 positions, etc. And then you apply at that level to get the F. And
yes.
So that, and you can't do it at 4 because then you'd need to be able to move the 4 positions out, and there aren't 4 positions to push it in. So this was very helpful to me in understanding what was going on.
Fair enough. Nice. All right, so the conclusion here is
we probably should allow any head, and I'm not, and then the question is, what happens when we do that? And I think,
well, wait a minute, aren't we using an allowed heads mechanism?
Well, we could also do that, and then the question is, what exactly does that mean? Right, it could, right, does that mean, does that apply at all levels that are being moved around? It probably doesn't matter what it does for things beyond where you push. But then there's a question of, list of things. I mean, I think we definitely should allow list of things which are not list as long as they're consistent, because I think that's certainly something people want, right? You have your collection of foo object, and you want to map thread, and that currently you have to, apply list before you stick it into MapThread in order to map thread. And it would be nice if you could just take your list of foo objects. Whether if we really need to allow level 0, I don't know. And I'm sort of reserving judgment until I see what happens once we.
Fine. Try it. Yeah.
Yeah.
All right. Should we move on?
Yep.
Okay. Table generalization.
Right. So this is an example, just of Python of the sort of thing. And
I understand. There's let me make a general point here. One of the things that we don't have because of 30 years of history or whatever, one might have a construct for each I in such and such list. And then what would it look like? I mean, it's very much an expa thing here, right? Yep. So this is, in fact, equivalent to our table expa I list.
Yep.
The fact is that it is very syntactically nice in code to be able to see something that reads more like this. I mean, it's very, very similar to this, but I'm just wondering whether there's anything useful we could get.
But it's not just table, it's do, right? And I don't see any semantic difference between do and for each. And so I was just wondering if instead of I comma list, you had I comma you know, k comma v, or maybe rule k goes to v. Could that just work?
All right, isn't that Sanders' proposal?
I think so.
Yeah. So my opposition has softened some since I first wrote this, because I discovered that table, even though this is completely undocumented, apparently table does allow you to use an association in place of list.
Really?
Yeah. See,
that would have been
even
useful.
Stephen didn't know that. So now I don't feel bad about not knowing that. So yeah.
Is that just the central dogma?
Oh, do I need to hit you? Do I need to send you to South Africa? But right, but it currently throws away the key, right?
Exactly. So that's why I was suggesting
what does it do
altering
here?
the syntax of the I there in order to indicate whether or not the key should be thrown out.
So what is it going to do here?
It's going to give you the list f of 1.
Oh, that's just totally crazy. That's just totally crazy.
Well, it's the central dogma. It's treating that association as the list of values.
Well, I think that's
How
crazy.
is that different from apply of f, throwing away the keys? Applying f to an association, throwing away.
Because it chopped the head off. Whereas this.
But anything that iterates over association makes sense to only take the values in general, unless you have a way to keep everything.
Well, I understand. I mean, but in this case, for example, if I say map over that association, it'll do that. And that's what I would have expected the table to do.
No, see, it's still the central dogma, because the point is that it kept the key. Oh, I see. So you wanted A goes to F1 and
that's what I wanted,
and
yeah.
B goes to F of 2.
Right.
But table should always return a list, right? So I think that will change too much table maybe.
Yeah, I could see that.
Right, and I guess that's the other question. What does if we do?
Well, that's in the theory that table must always return a list, which I agree doesn't seem like a foolish theory. That's completely blown up by having. Now let's see. If I did, okay, so if I say association map, F, A, B, right? I get that.
Right, and let me be clear, my objection isn't to the functionality. Like if we have an association table, I'm all for that. I'm concerned about sticking this into table because, well, this was before I was strongly opposed before I knew it currently accepted associations. But even then, even if we're using both the keys and the values, I think we probably want to return the list, because we can't guarantee that the resulting.
What if we introduced a new function that is the equivalent of, that is some syntax, foo, and I don't know whether it's, I don't know what the right way to do this is. And I don't know whether you need multiple, if you just do a one-dimensional case of this, what about the two-dimensional case? What about the association of associations, so I could imagine something that goes something like, for each I in, I don't know whether the term for each is right, I list, and then a level here. And what that does is it's the equivalent of map, except what it does is it takes expa, and for every I, so let's say I say for each, and I don't think the term for each is right here, but let's say that was I squared. I'm getting myself mixed up here. All right, let me try something. Let me try something here. Let's say for each I squared plus j, ij, and then a list, like this, where we don't actually need the level because we know the level because these are symbols.
Mm-hmm.
Right? I mean, in other words, this is a transposed version of a table-like construction. I mean, it's a combination. It's table meets map.
So the last argument is a list of tuples?
Yes, in that case, it's a list of ij forms. So for example, if I were to say for each I squared I, comma this, then it will be fed A, B, C, D. Okay, so let's see what happens with associations with this construct. Let's see. So here, if that's an association, so then we're saying, so what's the issue here? So we need both the key and the value. Is that the idea?
Yep.
So let's say it's I squared. I'm confused. So then what we want to do is, let's say it's key to the power value. And then the very bizarre construct would be something like this. And then we would have an association here. But then the alternative we might have is that this is just a V for value, and then it would iterate like a list over the association. And this would return an association. This would return an association as well. But in this case, it was only a function of the value.
And so it keeps the keys unaltered?
Yeah, I would assume so in that case, yes.
Well, in both cases, I don't see how you're declaring what the need.
Oh, yeah, no. But in one case, it's depending on the key. But in the other case, it's not.
Right, but in the resulting association, the keys are
the same as they were before.
Yeah.
I really like this I hadn't thought of this multi-level construct for this. Yeah, what would we call this thing?
Yeah, I mean, I would be fine with calling this for each, other than I would want the
structure as well.
our argument structure to be, transposed or rotated, I guess. Right, I would want.
So that for each is exactly a table where you transpose the.
No, it's
so
not.
You're saying
no,
for each
ij.
You're saying this. Oh, it's different because you are scanning them one by one.
Exactly.
And taking only the.
Yeah.
So Stephen's approach is inner. You are taking an outer there.
I see. So I will take the diagonal of my result. Yeah.
Okay, so this would say for each. It's a little weird that this has the evaluation semantics of this would be totally weird because it would evaluate its second argument but not its first and its third argument.
So it will be a hold last.
And hold first.
And would it also return something?
Of course it would return. It would return the result, the table-like result.
Yeah, which I
That's
guess
what I find surprising from other languages, to be honest.
Exactly.
And even
usually
just
don't return anything.
thinking about for in Wolfram language.
Okay, well, so maybe the name isn't right. The functionality though seems useful.
Oh yeah, sure.
Does it not return anything in these other languages?
No, because it's a for loop. It's syntactic sugar for a more complicated for loop.
Well, I guess the point is that here this is generalizing the iterator language, so we will end up with the various consumers of the iterator. Some product.
Well, but this isn't an iterator. I mean, this is not an iterator. This is
right.
No, but we could write it. Imagine that instead of list a comma list, we had list comma list. So we could incorporate this in the iterator language, and then it would work in all.
Wait. What are you suggesting?
Yes. So imagine table of expression list comma I comma j.
Oh, I see what you're saying. IJ.
Comma, then list of tuples.
Yeah, tuples.
Right.
Well, you're destroying my poor function again. But I agree, that's a nice syntax. That will be a useful syntax to have. I'm amazed that in 30 years we haven't thought of having that syntax before. Seems obviously useful.
So but if you support this,
sorry, the advantage of these, which is also more work, is that it would work in table, sum, product.
Exactly. Right. But I still think it's useful to have the syntactic simplicity of something, you know, well, you don't like the word for. You don't mind each.
Yeah, I think that's my sense of the objections as well.
My problem with for each is that it sounds very close to for all.
That's just because you know what for all is. I agree. I mean, but okay, but the functionality. So let's look at the functionality again for a second. If that was the order, right? I mean, it's kind of stupid because it's just saving you one list bracket. But it's a very elementary use.
This would be right. So if we implemented this in the core iterator stuff, so it also worked in do, then your for each guy would be right. So table could do. Well, I guess a bigger question is return values, right? What if you want to return an association?
Yeah, exactly. And the whole point here is that in the for each construct, you know, again, if this thing, well, this apparently already works. The list thing, wait a minute, that doesn't return an association there, which I find very bizarre. That doesn't return an association.
I think it's fine because in the same way that sum needs to return something with plus, effectively, table needs to.
All right. Well, then that's a good reason. Look, the main point. Let me make a very practical point. So, like in my elementary introduction book, okay, I do not introduce map. Okay, the idea of map-like constructs is useful, but in a sense, this function avoids anybody having to know about pure functions. Right? In other words, you could say, if you did this, if you said, you know, for each, you know, list of images, I'm now getting this the wrong way around. You know, I'm saying for each blur an image, images, yeah, I mean, the list of images, you know, as you're right to say that that's basically a table, but I don't think people use that table syntax very often. And I think it'd be much better if there was a single word there that meant this, because I think this is a very common construct. Admittedly, for probably more elementary programmers, I think that as soon as you get seriously into functional programming, you're not going to want to do this.
I mean, I think people might use table with the list, you know, iterator more than you think, precisely to avoid having to introduce map or pure function.
No, I understand that. But like, for example, in the IWL book, I made the decision to not talk about that table thing because I thought it was kind of a weird, to have to explain that syntax for something that is, I think, a very common type of operation is sort of embarrassing.
Mm-hmm.
So my question here is, and I mean, with this thing, the semantics of association could be quite different. So the question is, what would you call this if it was expr I list?
So that will be equivalent to a map with expression, right?
Well, except for the fact that the semantics of the variable are different. That's the whole point. The whole point is, unfortunately, our typical semantics, like for, I don't know, plot or anything else, it's like we go, okay, what's an example of a function that has, I mean, this is unusual semantics for us.
We could call it evaluate for or something like that.
That's extremely obscure. The notion of evaluate. I mean, the each is a really nice concept.
Mm-hmm.
But that's also somehow replaced in a different order, right?
Yes, that's right. Okay, look. For each, what would be look, basically the writing is for each I in blah.
I mean, this is really set construct or set build, right? Right, it's not for each I in blah. This is x such that, this is f of x such that x element list, right? I mean, if you want to say this accurately, right? This is open brace, expr, vertical bar.
Oh, but that's a set.
Right, but this is returning a set, right?
No, it's not. It's returning an ordered sequence.
Okay, fine. But to the extent that we represent sets by lists in the Wolfram language.
I know. That's the...
Mm-hmm.
The problem is that without an intermediate keyword, the for each doesn't make a lot of sense.
Mm-hmm.
Brian on our live stream is suggesting with each, but I don't think that really helps us. I mean, I agree that, what I'm doing, thinking about is something like this. But that is so freaking bizarre. Well, that's obviously unacceptable because that's just way wrong level. By the way, Ethan on our live stream is talking about key value map indexed. I wish we had a general way to refer to in a map, right? If we have #1, #2, et cetera, et cetera, et cetera. I wish we had a way to refer to, hash, picking a weird character, I don't know, hash question mark or something. Obviously that doesn't work to mean the index. Maybe that's a stupid idea. In other words, that's a stupid idea. Never mind.
I don't think it's inherently stupid. I mean, there's certainly been cases where, I've jumped through hoops to have, I've done a table over, I goes to length of a set, because I needed the index, and then I had to do, some part extraction on the set because I needed the element as well, and
right. I mean, having something which says, what is the index? The problem is it's so obscure what that would be. I mean, it's like the index stack.
Right, but that's in general a list in map indexed, which is fine.
No.
It's
I
sometimes
understand.
annoying, if you use map index, that it doesn't only give you the number, but the whole list.
Well, quite. Ethan is pointing out on our live stream, I'm now confused here. Oh, being able to, that's a funky idea. Being able to do full destructuring. So we got a table of an expression, and then to say something like
X, Y, list.
List of
Yeah.
X1, X1, Y1, X2, Y2. ... Okay. Well, and then that begs the question of whether, does this, I don't even know if, you know what, I'm embarrassed to say that I do not know if this works.
I don't think it does. If it did, I'm sure I would have used it.
Seems to me that would be a nice thing to have work.
Yep.
Since XY equals AB certainly works.
Interesting, the coloring colors that right.
As if it worked.
Right.
That's a good point. That's a good point. Well, that's a good thing. That will be a good thing to get to work, in my opinion. But look, I think this is an interesting idea which probably should be made to work.
But
how generally? Can I put an extra level of list around just the X's and?
I don't know. I'm not sure. Not sure. Whatever we're doing right now for assignment, it should probably do. But
sorry, I meant for the table, not. Which is where your mouse was at the time.
I understand that. But what I'm saying is, it's the same thing. It's an assignment, right? Think of it as a temporary assignment, which is what it in fact is.
Mm-hmm.
Right? The temporary assignment is made so if it works. So I don't even know if something like this will work. If I say that equals list AB. This is so scary. I hate doing assignments. Do you know? I hate it. Oh my gosh! What did that just do? Well, there's the answer. I gotta clear these variables before anything else goes wrong. No, but seriously, if that works.
Okay, so now try putting an extra level of list around A.
Here?
Mm-hmm.
What's gonna just set it? Okay, let's try it.
I'm not 100% certain that it's gonna do what you think it's gonna do.
I am. This is deep in the low-level nervous system of the animal. Yeah, I did the right thing.
Okay, maybe I must have been thinking of equal.
Yeah, it couldn't have possibly done anything different. That is so deep in the nervous system. I remember when that was implemented in like 1987. It's been in there ever since.
Okay.
It's older than some fraction of our users. Go ahead.
If we support this tuples way, which is what was also said before, then it will make somehow sense again this notion of key arrows value.
Exactly.
Yes, I agree. This is very close to that construct. This table thing, the thing that bugs me though is the failure to return an association when you give it an association as the payload there. By the way, I'm scared to even try it. Shall I try this as an L value, or is this just going to blow my whole?
You might clear X and Y again.
I did.
I thought you did one after.
No, I did clear them.
Okay.
Ah, phew.
I'm sure Tally just didn't get around to that.
Yeah, right.
Right, but I think if you set it equal to list 1, 2 on the right hand side, it will set X and Y.
No way. No way. Look what it just said. No way.
Try it.
I'll try it. Phew.
Okay.
All safe.
But the other way, X, Y as listed.
It won't work. They'll do something else wrong. But I think let's see, X, Y equals. There's no way this is going to work.
Okay, because there is some way where, oh, I know what it is. It's when you're doing part assignments that you might.
Yes, that's correct. Part assignment you can do.
Yeah.
On association thing. Okay, so listen, the thing that we're realizing here, which is highly interesting, is, wherever an assignment would work. So, I mean, there is an argument about whether this should work. I think there's a small argument that this should work. Okay, if that works, then
what
I
find
argue.
Weird here is that you specify values on the left-hand side, the X and Y. They're kind of.
Yeah, and I don't know what the evaluation semantics is for this, how the L value works there.
In JavaScript, there's a similar syntax, and what they do is basically they have an object that just has the keys. So in our world, that would be just A, B in the association delimiters.
What? That's weird.
Yep.
I mean, we can get the keys, obviously, but I mean, I'm totally confused by that.
I mean, it makes the most sense in terms of, what you want. You want to extract A and B from the association, right?
Well, here, that's how you do it, like this.
No, but you want to extract it. You want to extract them from the right-hand side of the.
I think Jan is talking about creating an association, but this is really about assigning to the values. So the values are needed.
I think it will be very confusing to have association equals some association. What do we do with the keys? What if the keys are
different
values or are values in the right-hand side, and I also want to assign the A and B to some value? That will be very confusing.
Right. Okay, so listen. One thing that I think is clearly desirable is the list-based thing that is precisely mirrors the assignment that's been working for 33 years, right? To be able to do that in table and with seems highly worthwhile. Okay, so there are two things still on the table. One is Sanders syntax for table with k arrow v, which I don't think is totally crazy. However,
it will return a list.
It would return a list. And it would also work in the case of sum and things like this. That would just work everywhere as an iterated construct.
I think both things are the same thing. So each of these constructors, table is associated to list, sum is associated to plus, etc. So if we want a new constructor that returns association,
oh sure, yeah,
we need a new name.
I see what you're saying.
Well, we could have an association table just for associations.
But what would return? The index associated with the value?
No, association table would be, it's actually pointless, because table, the whole point of table is it defines an iterator spec that is, based on, Z, the integers type thing, or, conceptually that, right? It's like a range.
Well, I was thinking it would just take an association iterator, the association.
Fine, but that's where I think we should be. I think we should be looking at a construct like this, which I think will become a very common elementary programming construct. Okay, because it avoids the need to use, I mean, I know we don't in fact need to use map because of the table thing, but that's somewhat obscure. So the question is, what is the best name if you're going to explain to somebody what it does?
I keep looking at that, and I keep thinking it wants to be an operator. Or whatever we're calling them.
Curried form.
Yes.
That's even weirder. That's even weirder.
It is, especially with
semantics.
the necessary hold semantics.
Right, because I mean, what would that actually look like? It would be for each...
that can't work. That can't.
Well,
work.
okay, independent of the can't work problem.
Independent of the can't work problem. Oh well,
it's impossible, but let's discuss it anyway.
Stephen, I would like to point out that we're way over time.
But we're having fun.
I know, but this is important. This for each construct or something like it is important.
Well, then it can be the first item on the next meeting.
I think Sander just reinvented function.
Yes, that's basically for each I expa list. No, what that is, that's map, right? For each I expa, that's function of list is the same thing as map. Function I expa list, if I'm not mistaken.
Or it's function with an implicit listable attribute.
Or using replace also. So you can use replace I rule delay expression and also apply to list.
Replace list thread.
No, but you can use replace as operator also. So yeah.
Right. So what are you suggesting? Replace
I rule delay expression and.
Oh, gosh, yes, that's horrifying. I mean, it's rule delay.
Delayed.
Yeah, to be sure it's pinned.
Well, you need to do this at level 1, right?
Right, you will need to map, of course.
Well, yes. and a better version of that is the very beautiful, underused thing of this kind. That's a function, right?
I was just wondering if we should just emphasize that more. Other than probably needing parentheses and places and whatnot, but
people will type it wrong. They'll type it as an arrow. It's not a good idea.
But looks very nice. Yeah.
It does look nice. Yes, it looks beautiful. Although I personally am happy with the use that we're making of rule. Okay, I'm sorry, just one more iteration of this iterator, so to speak. So the issue is we've got variable here that's iterating over a list here. I wonder whether there's anything like each value. Because we'd really like to be able to do expa I list. Okay. See, we've got to have a name that makes it obvious what the argument order is. I don't think we can justify that order.
No, but if you swap the last two, you almost could. And either of those two, it can be hold rest.
Yeah, I'm not concerned about the holding for that case. I mean, think about that, what that would look like. It would say each element ABC, for each element of ABC.
I mean, it ends up being very close to, the cases syntax, but without, patterns.
Or arrows.
Yeah.
I see, and you're saying without patterns. I mean, this again, it's sort of pattern, it's like a replace, as you were saying, it's like a replace all. It's like an unpatterned replace all. What a weird construct. I goes to I squared, where but for pattern.
Well, what it really is yeah. Wait, I was going to say, I think it's replace at level 1, but
it is, yes.
Yeah, you need to specify the level.
Yeah.
In that case, yeah. Well, with replace, not with replace all, right?
Yeah.
Which, I mean, is probably a reason then that you sort of benefit from tying the iterator variable I to the list in some form. Right? I mean, because like suppose you had that replace syntax as something that worked, or maybe that one.
Well, that one does actually.
Okay, that one does work. Yeah, but suppose you had some other function name that took something similar to that, and instead of the list ABC, you had a matrix. It needs to be something that's clear that it's not going full depth into the structure and replacing things.
That's just stupid. I mean, it's stupid to have that because that's so unbelievably close to table. It's just like, who cares?
Mm-hmm.
So the only real thing in the current proposal that we cannot do here is return an association from this.
Mm-hmm.
Which I don't miss in the sense that you can always use association, add, table, etc. So, and that will work.
What do you mean?
So you can apply association to the whole table construction.
Right. So your expression is key goes to whatever, and then you evaluate, you turn it into an association at the end.
I see. You're saying you say table, I goes to I squared, I goes to 4, and then you just say association of that.
Yeah.
Yeah, but that's a different thing. That's solving a different problem. I mean, that's then you've got the rather bizarre construct like this to do that.
Right, but if we supported key goes to rule, right, you could create whatever, you could do the same thing. And then the question is, I mean, what do we gain by having something that directly returns the association, which maybe we do, but it can't be in table.
No, I understand. I agree with that claim. Yes.
I mean, I think the obvious name for that would be like associate.
Oh, we have an associate, don't we?
It doesn't have a ref page as far as I can tell.
No, we have associate 2 and things like that. We have, don't we? We have
yeah.
What is it called? It's the it's an L value. It's a thing like append to.
Right.
Right.
I think this would be association table because it's to table what association map is to map.
Sorry, say that again.
I see it as an
Yeah,
association table.
it would be association table, yes, but it's a goofy thing because it's festooned in list syntax here, just to get something rather trivial out. Again, look.
Well, I mean, but if we are have something where we generalize the forms of iterators, then I like Jose's comment that sum is to plus, as product is to times, as table is to list, as and they all take the same.
As discrete plot is to graphics.
Yes. Sorts of specs. And you just have a function and its output type.
I understand. So I mean, you could in principle have association table or some such other thing, although I claim that that's not going to be terribly useful most of the time, because most of the time this is not a, the 1 goes to 2 goes to 3 goes to isn't a very useful thing. Okay, listen, we should wrap here. We're really late.
Maybe we can start.
But the as far as I'm concerned, the challenge here, so I mean, we have come to some conclusions about things we would like to do about these destructuring things, which I think are really worthwhile for both iterators and with.
Okay.
But the thing that remains open is the brilliant name for this thing with arguments in some order.
Okay. Talk to you later.
Yeah. Okay. Thanks all. See you later. Bye.
Bye.